Hey guys, and welcome to another video on efficient Python. And in this session, I want to take a look at sorting, which is a really commonplace action. Specifically, I want to take a look at the sorted function. So a fair bit different to the list.sort method, but the same principles are going to apply, which is where we're going to be using a function to basically dictate how our sorted function does its sorting. And I'm going to break this video down into 5 main bits. We're first going to look at just regular sorting. We'll then take a look at how to sort lists of strings with functions and then nested sequences with functions. I then want to then kind of loop back and look at how to do some of these using lambda expressions. So a nice way to save yourself a bit of code. And then finally, we'll take a look at how we can sort some custom classes of our own creation. So first of all, just a bit of background on the sorted function. It returns a sorted list. So if I was to run sorted and open this up here, we get this our kind of our return statement bit here. It returns a list, which is no surprise. And we can see this key none reverse bool equals false. If you do reverse equals true, obviously, of course, it's going to reverse the output. I'm more interested in this key bit here because that's where the real power of this parameter lies. So just to get the ball rolling, let's just quickly run this bit of code here. I'm in print sorted of names. Now, the way this sorts, it sorts on first glance in alphabetical order. So we've got Adam, Alex, and Alice here. However, I just want to show you something. If I was to then let's do a capital A for Alex and hit run. Now the order's different. Well, why is that? And that's because this does something called ASCII betical. And to kind of explain that, we need to kind of know a little bit about how the sorted function interprets these and chooses, well, where to put this. Is it in front or behind this? To know a bit more about that, what we need to do is figure out, well, what is the ASCII value of each of these things? And that ASCII value, then dictates basically, well, where it goes. That ASCII value then dictates if it goes in front or behind another element. Let me try something. If I was to say for name in names here, and I want to do n is equal to, let's do a quick list comprehension. If I do ORD of I, for I in name here. So basically for each name, we're making a small list comprehension and then we're going to print it. And inside our list comprehension, we're using ORD of I. ORD is going to convert a character, such as A, into its corresponding ASCII value. So if we go ahead and run this, bring it up so slightly here, that's our first one, Alex, this one here. Now notice the capital A has an ASCII value of 65. So in this case here, it's going to be putting this name right at the front because our uppercase A has a lower ASCII value than the lowercase a in Alice and Adam. So if you ever wonder why that happens, that's why. It's because it has a lower ASCII value. And of course, if this goes back, the lowercase a has an ASCII value of 97. So if we hit run again, there we go. And then, of course, it then jumps to the second letter and third and so on and so forth. And one more thing I want to quickly look at as well is what happens if you mix different types. So just to show you something really quickly before we do that, if I was to do 10 greater than 100, and then underneath, we'll do the same thing. We'll say B is more than A as a string. We'll get this ran. False and true. Okay, so Python knows how to compare these. Actually, behind the scenes, what it's using, if I used to do print dir of str, so dir of string, we're looking for, let's see, this lt, so this is our less than method here. There's lt and there's also gt greater than. These are the dunder methods behind the scenes that actually, well, these are what invoked to basically figure out if this is more than this. And then what happens if you then try and mix them? So if I remove this and then do 10 more than a here, hit run, I'll just copy that area into here for a second. Basically get this. So it's saying, well, this is not supported between int and string. And of course that makes sense because, why would the more than symbol work between a number and a word essentially? So this is quite common if you're trying to sort things which aren't compatible. So with that said, let's jump into the second part, which is how to sort list of strings using functions. Right, so jumping straight into our second part, which is sorting list of strings with functions. First, I want to discuss like why would you even need to do this? And I think what I've got here, if I zoom in just a little bit, let me show you this example. Suppose we have 5 people in our list. We've got different name prefixes. So we have Smith, Jones, Parker, Turing, Alexandra. Now, what if you wanted to sort this via this part of the name, so using the actual surname, disregarding this here. So if you imagine, if you were to sort this normally, it's going to start sorting via the MR, or the MI, or the the miss again here. So it's going to put your last names out of whack. So what you want to do is basically use a function to say, actually, don't sort via this first part as you normally would. Instead, take in this part of the name, and that is going to be your sorting metric. So let's just discuss kind of how that happens. If I was to say names is equal to sorted names, and then we're now going to invoke this key bit here. Now this does something really cool. If I just quickly say none for a second, basically what happens here is if you pass key is equal to some function, then each of these are passed to this function one by one, and whatever this function returns is then used as your sorting metric. So let's just quickly take a look at that for a second. If I was to do for n in names, and let's just do a really quick function to return this part of the name. So if I was to do def, let's just do last for now. Bit of a lazy name, but anyway. And to do this, we'll do return n dot split of -1 here. So if I say for n in names, print last of n, we'll go ahead and hit run. And there we go. Alexandra, Parker, Jones, Smith, Turing here. It's kind of similar to doing this. So imagine we had, if I do it as a comprehension, so last of n, and then we'll do that for each n in names here. Now imagine we were sorting this list instead. Print names now. Let's try that. There we go. Alexandra, Parker. So you imagine this time we're looking at the A, the P, the J, S, and the T here. We could even do something a little bit nicer. Let's just do lower. Make it all nice and uniform as well. Like that. So imagine rather than sorting this list by like the Mr. or the Mrs. etc., if we say sort it by what this function returns, we're actually sorting by these here. So all we got to do is get rid of that, bring our function above here, above where we've got our key is equal to, and say key is equal to last. And then this time if we print names, it's basically now going to say, okay, for each of these 5 names, pass them into here, lowercase it, and that's how I'm going to sort. So if we now hit run, there you go, Alexandra, Jones, P, S, and Turing. Yeah, there we go. Pretty easy, right? So yeah, I think it's a fairly simple example, but it's something that's pretty common. It's something I have to do quite a lot for work as well. So knowing kind of just how this key parameter works can really help you kind of improve how you're sorting and how you're kind of using Python on a day-to-day basis. So for this second example, imagine we want to sort our list, but of course, sorting it normally is going to mean we're looking at this in this alphabetical or ASCII-betical way. What if we wanted to sort these by the length of the string? And that'll be pretty simple. We already have a built-in function which does so. So we could say sorted, pass in cities here, and then our key is going to be the built-in len. So this means, imagine len going over this, we're going to get 9, 5, 6, 7. So it's just going to sort by those numbers, which is pretty nice. So all we got to do is print cities and take a look what we got. If I was to do, sorry, not sorted, reverse. There we go. So we were to do reverse is equal to true. Just see them sort backwards now. Yeah, just like that. So this time it's saying sort cities, so return a sorted list. The way upon which you're going to sort is by using the len function. So pass these to the len function, and whichever numbers come back, sort that way. Okay, so this last one for this section is going to be a little bit different because these are technically going to be lists of, pathlib items, so not necessarily strings. I want to show you something quickly I've got here. I've got a random list of files, some CSV files, some text files, and a Python file here. A really common thing to often do is to try and sort things in directories based on, could be their suffix, could be their creation time, their mod time, their access time, could be anything like that. So I want to show you for this example something probably a bit more practical. We're going to create a list of items from this directory. Here we are, inside files. And we're then going to sort them by their modified time. So let me show you how I'm going to do this. I'm going to do, let's call this list files here. And we're going to say path. I'll use a relative path. You can use the absolute if you want. And it's going to be inside files here. And then if I do .glob, this is basically going to say, look in here for anything with. Now, normally you could do something like .txt. That'll find any text file. If you just do this though, it'll just give you everything, which is quite nice. And let's print it off. Now this returns a generator, so we will need to convert this. Yeah, that's absolutely fine. So if I do list like this, we should convert this to a list. And there we go. There's all our things here. Now, the way we're going to do this, let me show you quickly just one small example. If I ask for number 0, so this guy here, this iMac 2021, and then if I do .stat, so let's call that. This is quite an interesting function, and it gives you all of these little things here. So you have access time, modified time, we've created time, and from .stat we can then access those things. So we can do st, and we are looking for mtime, modified time. And you get this little kind of Unix or epoch timestamp, which is quite cool. We can actually use this as the key to sort all these files, which is quite nice. So just do that. I'm going to shelve that for just a second. We'll do list files, and we'll say this is equal to sorted. So bear in mind this is already a list, so we're sorting an existing list here. We'll pass in list files, and then for our key, what we need to do, I'm going to just put none there for a second, is we need to now define a function to basically take in some file and return this of it. So if we do def, call this mod time here, not tile, mod time. So we'll call this mod time. Let's just do f for file. And then here, we're basically going to do this. So if we do f.stat.st of mtime here, and this is going to become our key. So if I do key is equal to mod time, I'm just going to hit run, check there's no errors. No, we're good. And if I do print list files, okay, it looks good. So to prove this, let's look at one that's in the middle. Let's do that Python one there, and let's just do x equals 10. Lovely. Hit run again, and now we can see that. Look at that. Our Python 996 is now right at the end, because of course its modified time has changed. So you figure out why that's changed. That's because we modified this at a later time, right? So of course, because these ones had an earlier modified time. So suppose if you did want to get like the newest files first, we could do not sorted. We do reverse equals true. It's one error after all these years I still seem to make. There we go. So you can put on newest files at the front. So say we now edit our CSV. We'll put some stuff in there, change that. And now our CSVs are at the front. So you've had some sort of program which was, iterating over a list. It was looking at files and doing some kind of processing. This would be a really kind of nice way to say, always put the newest files right at the front. And of course, it's all done just by saying sort them and use the modified time as the metric of sorting. So for our nested sequence example, I've got a 4x4 grid with some small integers. And what I want to do is use a couple of basic functions to show how we could sort these in different ways. So if I redefine it, in fact, what I think might be a bit clearer here is if we do like a pre and then a post here. So we'll do pre-nums, then we'll do nums is equal to sorted. We'll do our stuff inside here. Then we'll take this line here. We'll put this guy down below. So we'll do pre and post, and then we'll hit run. So let's look at a few different ways we could do this. Now, because we have lists of numbers here, now let me try something. Can I also do nums and then do key is equal to? So envision that whatever is here, this entire thing is going to go to that function. So for our first key, let's do key is equal to sum here. So if we were to do sum, envision that you gave all of this to the sum function. It'll do 1 plus 6 plus 9 plus 3. So basically we're ordering these by their sum. So if we run that, of course, this guy here is going to be our biggest one because that's got 2, 3, what have we got? 2, 5, 3, and 9. However, if we made this guy have 100, then that should then go at the end. There we go. Let's try key is equal to min. Now imagine all of these going into the min function. Actually, it should be the... Yeah, that's got the zeros in. So now this guy's at the front here. So if you take the min of all these, we've got the min of 0. The min of this is going to be 1. Min of this is going to be 1 as well. So just something to bear in mind, you can use any... if you've got a built-in function that can take a list and give you something back, then that's perfectly fine to use as the key, as long as it serves you some kind of purpose. What if you wanted to do I suppose the average. Now that'll be quite a nice one. And with this one here, we're also going to touch on section 4, which is how to do it with a lambda as well. So if I just was to do def, let's do average, and we'll do LST, just short for list here, and then we'll do return the sum of LST divided by the len of LST. And all we got to do is switch out this, put average in here, and then we should be good to go. Nice. Just to kind of prove this is being called as well, I wouldn't normally do this in practice, but to prove that function's being called. There you go. You can see the averages coming out just there. Two of them even have the same, which is quite nice. Let's make that a bit bigger. I think it's that one. It is, yeah. So yeah, we're printing off the return value at the same time. So let's get rid of the prints, clear the screen, move the space up a little bit. And yeah, that's it really for this one. What I want to do now is show you how we can kind of convert this into a lambda. Now this one's a bit tricky because I think deciding when to use a lambda or not is kind of up to you. I think for me, the golden kind of rule is if this can be done as a lambda and I never have to use this function again, it should be a lambda. Because you think the normal use case of a function is that this is a reusable block of code, when if you're just using it here, it's not that reusable, is it? So to convert this, it'd be quite easy to be honest for this one. It looks something like lambda LST colon this. So rather than doing key is equal to a reference to a function, we have key is equal to this function here, just like that. Maybe we want to do one where, suppose we're sorting the arrays by the last value. That'll be fine. So our lambda takes an LST, a whole list, to get the last value, LST of -1. And there we go. 0, 1, 3, and 9. So suppose this 0 now became 78. There we go. We're stuck right at the end there. So let's clear the screen and we'll take a look at our last section, which is sorting custom classes. So for my custom class example, I have a class called person, which takes name and age. So each person's going to have a name and an age. And this repr here is just used for printing off people when they're inside a list. To set up our objects, I've got a string names, which is John, Sarah, Alice.split. So that's 3 separate strings. And ages is defined as this tuple here. The way I've defined my people is inside the list in a comprehension. So I've done person NA for NA in zipped names and ages. So basically, it's going to make 3 people with John, Sarah, Alice, which have the corresponding ages of 45, 23, and 21. So if we hit run, see what we get. Okay, we got John, Sarah, Alice. That's because I've done self.name here. You could beef this up if you wanted to do like an F string. So you could do something like this. Let's put self.name inside here. And then what you could then do, just so you can see the age in the output, you could do that with, if you wanted to make it a bit more kind of visible. Actually, I suppose with the lists, maybe it's not. So we could do this here. Maybe that's a bit nicer. So John 45, Sarah 23, and Alice 21. Now, when it comes to sorting custom classes, you've basically got 2 ways you can do it. One is using key is equal to lambda. Then that lambda just looks at the age attribute. The second way is to actually implement a comparison method inside here. We'll do both. So let's just do, so say I've got people here already. We'll use that as kind of like our benchmark. Just hit run there. And then what I'll then do, let's just do P. Actually, let's just do, I shouldn't use this variable names. So use the proper ones. Sorted. Okay. Sorted people. And then our key is going to be lambda. We can do lowercase person. That's fine. The class is the title case. That's okay. And then we'll say of this person, return. If we did the age, that will sort them. I'll sort them by their age, as you probably guessed. So we did sorted people now. There we go. So now this puts Alice at the front here. So let's just pause and recap that. So sorted people is equal to a sorted list. It's sorting this list of people here. And the way it's doing that is by saying for each person, pass them into this lambda. So in a person goes. And then on the output, we're saying return that person's age. So we're looking at 45, 23, and 21. And that's how it's sorting them. Suppose John is only 5 years old. There you go, now John's at the front. Suppose you want to sort your people backwards. You can do that. We can sort them in the other order, and that's totally fine. Now the other way of doing this, let me blank this off for just a second. Let's see, is to actually implement like a comparison method. So I also do def. Now this is kind of interesting. How this kind of works. I know this kind of goes more into the realm of like OOP. If I did like, person A less than person B, person A goes in as self. The thing you're comparing it to goes in as other. So we can say return self.age is less than other.age here. Now just a kind of a pitfall on this is the thing you are comparing a person to has to be another person. You can get around it by putting kind of error handling in here, but if I was to now do, let's try something, people.sort like this, clear the screen and hit run. See, just like that. If we were to now do the same thing again, we could pass versus true in here. Same thing. Let's now get rid of this. Yeah, see that? So now because this doesn't exist, the sort method in this case is this now a method because it's been called on a list. Doesn't know how to compare people, but if we give it that mechanism to say, here's how you compare instances, then yeah, it knows how to do it. And that's it really. We'll round the video off here. And later on this week, I've got a nice video coming up on multi-threading. Cheers for watching, guys, and see you all soon.